Another area of cognitive psychology is memory. And memory is what we're talking about when we talk about retaining learning over time. There are three processes for any memory that you've ever had. The first is encoding. This is where you're trying to get information into your brain in the first place. Then once it's in there, you have to be able to store it or retain it somehow. And then when you want to use it, you need to retrieve it or get it out of your brain. All memory requires all three of these processes. You can't form a memory without one of them. So let's talk about some specifics within each, starting with encoding. There are generally two types of encoding. There's automatic encoding, which happens when you don't have to put any energy or effort into it. So for example, if I asked you what you ate for breakfast, you probably could remember automatically. You didn't have to spend time trying to memorize that. And then there's effortful encoding, which is when you do have to put in some energy and effort to get information into your brain. So in school, this is what a lot of the encoding is you have to look at ideas over and over again to get them into your brain or have them encoded. When we're talking about effortful encoding, one technique that's useful is rehearsal, which is just conscious repetition, repeating the information over and over again. Maybe you've gotten a new phone number at some point and just said it to yourself out loud or in your head numerous times in the hopes that it would stick. Maybe you've been a student who's made flashcards. Flashcards are a form of rehearsal where you make a term on one side and its definition on the other side and spend time going through them over and over again in an effort to learn them better. And generally, the more time you spend rehearsing, the more information gets encoded into your brain. However, you have to keep in account the timing of your rehearsal. So many of you maybe have used the cramming method to studying, and I'm here to tell you that cramming is one of the worst things you can do when it comes to studying. It's a way of shooting yourself in the foot and ensuring that you're not going to do the best that you possibly could. And the reason for this is because of something called the spacing effect. Basically, the way our brain is set up is that it encodes information better when you rehearse a little bit here and a little bit there, when your energies for effortful encoding are spread across time. We get information into our brains more efficiently. Additionally, we remember the first things we learn and the last things we learn the best, and this is called the serial position effect. The information in the middle is oftentimes harder to remember, but the stuff that was first and last we know the best. Also, another way to make information get into your brain easier is to make it personally meaningful. So if you're learning about an idea in class, you want to come up with a personal example that applies that idea from your own life or from someone you know's life so that you can remember the information more easily. This is oftentimes because there's an emotional context. So now moving on to storage, there's three major types of storage. There's sensory memory, short-term memory, and long-term memory. Sensory memory is the immediate, fleeting record of the sensory information coming into our body. So your brain holds on to everything that you see and smell and hear for just a couple seconds. So maybe you've been yelled at by your mom before and she says to you, "You're not even listening to me." And you say, "Yes, I am," and repeat back what she just said, even though really you weren't listening. The reason you were able to do that and repeat back the few things that she had just said was because of your sensory memory. So if your mom really wanted to get you, she should say, "You're not listening to me. Tell me what I said a minute ago," and then you would be caught. An example of the kinds of sensory memory we have is iconic memory, and iconic sensory memory is what comes in through our eyes. So you do have a very short-lasting photographic memory. There is a visual illusion posted after this lecture that you can try that uses iconic memory to make the illusion happen. So the next is short-term memory. Oftentimes this is referred to as working memory because this is what's activated right now. Generally, we have a small capacity for our short-term memory, and the capacity limitations that they've been able to identify in the human brain is 7 plus or minus 2 items. That means you can hold on to approximately 7 things in your short-term memory at once. And then from there, either the information is rehearsed enough that it goes into your long-term memory or it's forgotten. Long-term memory is relatively permanent and limitless, meaning that you aren't ever going to fill up your brain in your long-term memory. There's never been a person who couldn't learn any new things or make any new memories because their brain was full. That's not happened. There are two kinds of long-term memories. The first are called explicit memories, and these are memories that we have to consciously recall. So when I ask you what you ate for breakfast, that would be an example of an explicit memory. This is related to both the personal experiences, like the breakfast, or facts. So if I asked who the first president of the United States was, that would be part of your explicit long-term memory coming into play. Interestingly, when we are born, we don't have the ability for this kind of memory, so no explicit memory before the age of 2 to 4 years old, and this is referred to as infantile amnesia. And the reason for that is that the part of the brain that's in charge of this kind of memory just isn't developed enough yet. That's not to say that babies don't have any memory. They do, but what they have is implicit memory. They don't have explicit, but implicit. And implicit is what we can do without conscious recall. So these are our very basic motor skills and cognitive skills. So if you were to think about tying your shoe, for example, you probably don't have to think about it anymore. It's become implicit without conscious recall. You can just do it. Or if you've ever had the experience where you were driving home and thinking about something else and somehow you ended up home and you don't remember getting there, that would be implicit memory. And then any of the classical or operant conditioning effects from what we talked about last week, so any kinds of consequence learning or association of stimuli, would also count as implicit memory. So then on to retrieval. Retrieving information out of our brain can be complex, and there's two different ways that this can happen. We can either have recall or we can have recognition. Recall is where we're asked to pull things up without any prompts. Recognition is where you're given some hints and then your brain is able to pull the information out. So if you think about this in the context of school, a recall retrieval test would be an essay test, because there you're asked a question and you have to remember all of the information for yourself, as opposed to a multiple choice question, which would be a recognition question that gives you the answer. It's somewhere there. You just have to be able to pick the right one out. And in general, recognition is much easier than recall. One of the interesting things about retrieval is that context matters. And there was this interesting scuba diver study. In this study, they asked people to memorize a list of words. And there were two major conditions. One where the people learned the list of words on land, and another where the people learned the list of words while scuba diving underwater. And then within each of those major conditions, they broke them off into two sub-conditions, so that of all the people who learned the list of words on land, half of them were asked to recall that list later on land, and the other half was asked to recall that list later underwater while scuba diving. And then the same thing for the scuba diving group who learned underwater. Half were asked to recall on land, and half were asked to recall underwater. And these are the results. We can see that the two bars on the right, which are the bars that indicate the best performance, there's the most words recalled, are the ones where the place where they learned was the same as the place where they were tested. So the first word in each pair is the place they learned, and the second word is the place they were tested. The two green bars on the left, where the place they learned and the place they were tested are mismatched, did not perform as well. In addition to context, mood is important. Mood congruent memory is this phenomenon where we tend to recall memories that are consistent with our current mood. So when we're feeling happy, it's easier for us to recall happy memories. When we're feeling sad, it's easier for us to recall sad memories. And this will become important when we start talking about depression at the end of the semester. So those are the three major processes: encoding, storage, and retrieval. But it is the case that we sometimes forget, and there's lots of places where forgetting can happen. It can happen in encoding or storage or retrieval. So an encoding failure, what we mean when we say we forget, is that the information didn't make it into our long-term memory in the first place. Oh, I forget what she said in class, is probably because it didn't actually get past your sensory or maybe even your working memory and into your long-term memory. Maybe it did get into your long-term memory, but you haven't used it in a long time. One of the things that happens is storage decay, where if you know something but don't continually reuse it or strengthen the connections between those neurons in your brain, you will eventually forget the information. This graph shows the number of vocabulary words that a person learned in a Spanish course, and you can see that the rate of recall is very high immediately after the end of the class, but just a couple years later it drops off quite significantly. And then there's retrieval failure. And retrieval failure happens when we aren't able to pull the information out appropriately. And one of the reasons this might happen is interference. Sometimes we can't remember the name of a new teacher because we keep thinking of the name of the old teacher. Or maybe you're trying to remember your old phone number, but you can't think of anything but your new phone number. That's interference, where current or old information is conflicting and causing you to pull out the wrong thing. There's also the tip of the tongue phenomenon, which is where you're trying to remember something and it's right on the tip of your tongue, but you can't quite get it out. So maybe the name of a movie, for example, you're trying to remember the title and you just can't, and you know that you know it, but you just can't get it out. And oftentimes what will happen is that you'll remember it later, either in the middle of the night or in the shower or the next day. And that's because your brain actually continues to try to work to find the information, and once it does, that's when you have the aha, I remember moment. We also can engage motivated forgetting. Sometimes we don't want to remember things because they're too painful or upsetting, and so we try hard not to think about them or not to remember them. A couple of examples of extreme forgetting are amnesia and Alzheimer's disease. So amnesia is what happens when we lose the ability to have memories, either short-term or long-term. There's different kinds of amnesia, and this almost exclusively comes from head trauma, either a stroke or an accident of some kind where the brain has been damaged and is not able to pull memories out appropriately. We're not going to really spend any more time on amnesia. Alzheimer's disease, however, is a biological disease of the brain that we are going to talk about quite a bit when we actually meet in class. So a few things I want you to know about Alzheimer's disease is that this is a kind of dementia. Maybe you've heard the term dementia before, and if dementia is a large spectrum, Alzheimer's is the worst kind of dementia out there. And what happens is the brain basically starts shrinking. Lots and lots of connections and neurons die. So on the left we can see a healthy brain, and on the right we can see an Alzheimer's brain. And you'll note that it's smaller in size and that there's quite a few big holes in the middle. So when you're losing connections, you're probably going to start having a hard time with things like memory. The cause of these neurons and connections dying are things called plaques and tangles. And here we see some examples. On the left is a computer-generated model, and on the right is some actual brain tissue. And these are places where various proteins conglomerate and basically choke off the cells. So eventually the cells will start dying, and then their connections will start dying, and this is when you start to get Alzheimer's disease. This is a terminal disease, which means that it eventually will end in death, and that's because at some point the brain degradation is going to get deep into the brainstem and you won't be able to keep your heart beating or your breathing happening anymore. And there's 7 stages, and what we're going to do in class when we meet again is I'm going to show a video that'll show an example of each of these 7 stages so you can see how it starts and how this disease ends. So the overall picture I want you to get from the memory chapter today, and that we'll reiterate in class, is that memory is not perfect. We oftentimes think about it as if we remember perfectly and that our memory is right and other people's memories are wrong, and that's just not the way that it is. All of our memories are wrong and susceptible to bias, which we'll learn more about in class.